Welcome to Mrs. Neller's notes for her pre-calculus class. These are the notes for section 1.2, day 1, entitled Exponents and Radicals. And our objectives for today are going to be to review integer exponents and review the rules for working with exponents, as well as scientific notation. So we'll be working with the first 3 objectives today. So let's take a look at some integer exponents. And this little box is in your book as well, and this is just a reminder for what the rule for writing an exponent is. When we have a product of identical numbers, like 5 times 5 times 5, we can rewrite that in exponential notation. So we would rewrite that as 5 to the third power. And this little box explains that, and it just wants to, refresh your memory that the A at the bottom there, that's the base, and then the N up at the top, the small superscript, that's the exponent. So in example 1 here, we're just going to evaluate these exponential expressions. And for part A, you have 1/3 raised to the 4th power. So what you can do to simplify this is basically distribute, in a way, distribute that 4th power to the numerator and to the denominator. So you'll have 1 to the 4th over 3 to the 4th. And 1 to the 4th power is just 1, and then 3 to the 4th power is 81. And yes, you can enter that into your calculator. Your calculator will give you a decimal though, so then you'd have to do math, enter, enter to get the fraction back. That's the keystrokes for if you have a TI calculator. For part B, when you're raising a negative number to an even power, remember that is going to get you a positive number. So this is really like -3 times -3 times -3. So it's -3 times -3 times -3 times -3. So when you multiply 4 negative numbers together, you get a positive, and when you multiply 4 3's together, you get 81. And then part B and C are slightly different just because part C doesn't have the parentheses, so that does change whether or not our answer is positive or negative. Here in part C, the only thing that is being raised to the 4th power is the 3. So that negative is out front of the whole expression. So here, when we simplify this, we get -81. And usually part B and part C are what get confused the most by students when they enter them into their calculator. So when you put these into your calculator, if you're taking a negative number and you're raising it to some power, you have to put parentheses around it, just like in part B. If you don't, you'll get the answer that we got in part C, and that will be incorrect. Now when you have 0 as an exponent, remember anything to a power of 0 is 1. Anything. It could be the square root of 2 to the power of 0. It's still 1. And hopefully last year you worked a lot with negative exponents and rewriting them. Basically, when you have a negative exponent in the numerator, you're going to rewrite your expression and move that term that's in the numerator down to the denominator. And when you do that, it changes from a negative to a positive exponent. And it works the other way as well. If you had a negative term, or if you had a term with a negative exponent in your denominator, then you would rewrite that so that the term moved up to the numerator and the exponent became positive. We want to try to avoid negative exponents whenever possible, so we want to rewrite our expressions so that they have positive exponents. So that's what we're going to do here. Okay, we're going to practice the 0 exponents and the negative exponents. So in part A, remember, anything to a power of 0 is 1. It's not pi to the first, it's not the square root of 3 to the first, it's just 1. Now for part B, this is 5 to the -3rd power. So that means we're going to take our inverse, basically. We're going to move that 5 to the 3rd to the denominator. Here, it's in the numerator. You can assume that it's all over 1. So when we rewrite it, we move the 5 to the -3rd power down to the numerator And when we do that, it becomes 5 to the positive third. So now we get 1 over 125. And again, your calculator can do that for you. You can type in 5 to the negative third power, but it'll give you a decimal. So then you have to change it back into a fraction. And part C, the only thing that's different here is that we have a negative 8 being raised to a negative 2 power. It's the same concept as in part B. So I'm going to move this to my denominator. When I do that, the 8 stays negative. It's just the 2 that becomes positive. Because in our original problem, we had the negative 8 to the negative 2 power all in the numerator. So now when I move it to the denominator, just the 2, just the exponent changes the sign, not the actual base. So that's a common misconception too. Students want to take away the negative from the 8. So now when we simplify this, we'll square our negative 8 and we'll get a positive 64. So we have 1 over 64 for our final answer there. Okay, so when we're working with exponents, we want to review these laws for exponents. And you should be very familiar with these. Law 1 says if you are multiplying your bases together, you can add your exponents. Law number 2 says if you're dividing your bases, you can subtract your exponents to help you simplify. Rule 3, I like to call this a power to a power. When you have an exponent that's being raised to another exponent, so you have a power to a power, you multiply. 4 and 5 are very, very similar. This is what we saw in example 1. And if you have more than one term inside the parentheses and it's being raised to some power, you're kind of like distributing that power to each term that's inside the parentheses. So ab to the nth power becomes a to the nth and b to the nth. And with a fraction, you can break that fraction apart and give each of them their own exponent. So we're going to work with those rules in more complicated expressions now. So in example 4, in part A, we need to look at this whole expression and we need to see where we should start simplifying. And this first term in the first set of parentheses is pretty much as simplified as it's going to get. But this second set of parentheses here, we can simplify that further by distributing that third power to every single term inside the parentheses. So we'll have 3 to the third power, which is 27. We'll have a to the third, which is just a to the third. And then we'll have b to the fourth to the third. So I'm going to kind of write that off to the side so you can see it. This is where we have a power to another power. So that's where we multiply those exponents. So we're going to get b to the 12th. And then I'm just going to leave my first term as is. And now the only other thing to do to finish simplifying this is to actually multiply out my terms. So 2 times 27 is 54. I multiply those numbers together. And my a terms, I have a to the third and a to the third. So when I multiply my bases together, the a's are being multiplied together, then I add my exponents. So I get a to the 6th. Same rule for the b's. I'm multiplying the b's together, so I add my exponents, and I get b to the 14th. So you should be able to work your way through that problem very confidently and with accuracy. Part B is a little more challenging just because it's fractions, but don't be afraid of that. In the first part here, we are going to distribute that third power to the numerator and the denominator. So we'll have x to the third over y to the third. And then in the second set of parentheses, it's kind of like what we did in example A there. I'm going to distribute that fourth power to every single term in the parentheses. I just have more terms than I did in my first fraction of x over y. So now I'll have y squared to the fourth. So I'll have a power to a power. So I'll end up with y to the 8th. So I'm multiplying the 2 and the 4 together. Then I have x to the 4th and z to the 4th. Now remember, technically that x and that z in the original problem, they're to a power of 1. So we're still doing a power to a power. It's just 1 times 4, which is 4. Okay, then I'm going to make this one big term. I'm going to get the whole numerator together and the whole denominator together as much as I can. And the numerators, if I look at them, they both have x's. So as I multiply across the numerator, I'm going to be adding the exponents on the x's. So I'll have x to the 7th and y to the 8th. And then in my denominator, I'll have y to the 3rd and z to the 4th. I can't combine any similar terms there. But I'm not quite done. I have one more step. I can cancel out those y's. I have 3 in the bottom and 8 on the top. So this is the rule where we get to subtract our exponents. So you can also think of it like canceling. If I cancel out 3 y's on the bottom, I have to cancel out 3 y's on the top. So 8 minus 3 is 5. So this leaves me with x to the 7th, y to the 5th, over z to the 4th. So that is my simplified answer there. So these problems tend to get complicated just because there's lots of rules and lots of properties going on in one big problem. So we had at least 3 different rules for the exponents that we applied in example B there. But just take it one step at a time and you'll do fine. And here are a couple other rules for exponents, and these apply to the negative exponents. And you can approach these problems a couple of different ways. For number 6, law number 6 here, you could still distribute that negative exponent to the numerator and to the denominator, and then move any negative exponents from the numerator to the denominator, or from the denominator to the numerator. But when you do that, it's really like ending up with b in the numerator now and a in the denominator now, and then you have a positive exponent. So you could do it in 2 steps, or you could use this law and do it in 1 step. Same thing for 7. 7, they give you the negative exponents, and then you can rewrite it so that they have moved from the denominator to the numerator. B has moved, or A has moved from the numerator to the denominator, and then the exponents change signs from negative to positive. So that's what we're going to take a look at in this next example here, example 5. When we see problems like this, I like to start by moving any negative exponents around first before I start using those other rules of exponents, like when I multiply the bases, I add the exponents, or if I have a power to a power, I multiply. So I like to get rid of all the negative stuff first. So in part A, this t to the negative 4 has a negative exponent, and this s to the negative 2 has a negative exponent. So those are the only 2 things that I'm going to move. So the 6 and the s are going to stay in the numerator, but the t to the 4th is going to move down. I'm going to put him at the end because I'll have my other part of the denominator in just a moment. So now in the denominator, the 2 is still going to stay there because he doesn't have a negative exponent. And the t squared is also going to stay there because the 2 is positive. But this s to the negative 2, that's going to move up to the numerator and become a positive 2. So now I really have all my s's in the numerator and all my t's in the denominator. So I have 6 s to the 3rd. So now since I'm multiplying those together, I can add my exponents. 1 plus 2 is 3. And then I have 2t to the 6th. 4 plus 2 is 6. And I can't simplify my variables, the s and the t. They're not like variables, so I can't subtract the 3 and the 6, but I can reduce the 6 and the 2. So I'll have 3s to the 3rd over 1t to the 6th. You can put the 1 in there, or you can leave it out. Now for part B, this is the rule that I was explaining on the previous slide, where you can either distribute the negative 2 and then move the stuff around, or you can just flip-flop it and make it a positive 2. Okay. Again, my personal preference is to just kind of distribute and move it. Okay. I think that usage of the rules kind of avoids any simple errors that students tend to make. So this will be y to the negative 2 over 2 to the negative 2 and z to the negative 4 now. It's 2 times a negative 2 is a negative 4. But now, since every term has a negative exponent, I'm going to completely reciprocate this expression. So the y squared is going to move to the denominator, and then the negative 2 will change to a positive 2. And then my 2 squared from the denominator will move up, and my z to the 4th from the denominator will move up as well. And again, I don't have like variables, so I can't simplify them. So the only thing I can do in the numerator is do that 2 squared, which is 4. So I'll 4z to the 4th over y squared. Okay, last concept for today is scientific notation. I hope by now you know what scientific notation is. It's a way to rewrite a really, really, really big number or a really, really, really big decimal. It has a number. I call it A here in this little box. And it has to be between 1 and 10. It can be equal to 1, but it cannot be bigger than 10. Okay, so it can be between 1 and 10, but it has to be less than 10. And so we'll have 1 times 10 to some power. And that power down here can be positive. If it is positive, that means our decimal gets moved to the right. And if our exponent is negative, then that means that the decimal in the number gets moved to the left. So again, those are concepts you should be familiar with. Okay, so we have example 6 and example 7, and then we're done. So example 6 is just rewriting these numbers in scientific notation. So we have control over this. We have a choice. We get to put the decimal somewhere in this big number so that it becomes a number that's between 1 and 10. So if I put the decimal there between the 5 and the 6, then I'll have a number 5.6, blah, 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 that is between 1 and 10. So this will become 5.692. Anything that's a 0 or a repeating 0, I can drop out if it's at the end of the number. So I'm not going to put that 0 at the end. But I do want to count it when I'm dealing with my place value, with the number of places that I've moved the decimal. So if I put the decimal between the 5 and the 6, I'd have to move it 1, 2, 3, 4 times to get it back to the end of the original number. So I'm dropping out the 0 when I'm rewriting it, but I have to count that 0 when I'm dealing with the exponent and picking the power. And then for part B, this is a really big decimal. So that means our exponent is going to be negative. And again, I get to choose where I locate the decimal. I need it to be not a number that's less than 1 like this. I need it to be a number that's between 1 and 10. So I'm going to relocate the decimal between the 9 and the 3. Because 9.3 is between 1 and 10. So it's 9.3 times 10 to the, and I have to count now, 1, 2, 3, 4, 5. If I move that decimal 5 places to the left from where I put it, it will return me to the original starting number again. So here, the negative indicates direction that the decimal moves. So does the positive. The positive exponent tells us which way the decimal is moving in the original number. The other thing we can do with scientific notation is pretty cool. We can multiply and divide in scientific notation. We don't have to actually rewrite these numbers all out and then divide them and then put it back into scientific notation. We can simply multiply or divide the numbers and then either add or subtract the exponents using our rules for exponents. So in part A, I have 1.062 and then 8.61. and they're being multiplied because between the parentheses, we have one scientific number multiplied by another scientific number. So I'm going to multiply them together, and I get 9.14382. And then I'm going to multiply my 10 to the 24th and my 10 to the 19th. So when I'm multiplying those bases, I'm essentially adding my exponents. So 24 and 19 gets me 10 to the 43rd power. It's pretty slick, huh? And I can do the same thing for part B. I can take my numbers, the 3.542, and divide it by the 5. When I do that, I get 0.7084. And then for my exponents, I have a 10 to the negative 6 divided by 10 to the negative 4, or 10 to the positive 4. So my rule is that I can subtract those two. So negative 6 minus 4 gets me a negative 10. Now, unfortunately, this number is not written in scientific notation, so I do have to do one extra step at the end where I relocate this decimal. So I'm going to make this 7.084 so that that lead number is now a number between 1 and 10. And when I do that, I also have to adjust my exponent. And this is kind of a tricky part. You just kind of have to think through it. I have to think, okay, originally, where my decimal was originally located, this was 10 to the negative 10. So that meant from this spot, I had to move it 10 places to the left to get my original number back again. Now, I just took that decimal and I moved it back one more place. So now, instead of moving it those original 10 places to the left, I also have to move it an additional one more place to the left. So I am now going to have 10 to the negative 11th power. So when you're dealing with those decimals, kind of think of it like standing in line. Here the original decimal was at this point, and he had to go to the left, and then for whatever reason he had to step back one in the line. Now he's got 11 places that he has to go to the left. So there's your practice problems for this evening. Remember, the O's are odds, so I know it looks like a lot, but it's a lot of odd problems. These are quick concepts. It should go relatively quickly. If you have questions, come on by my classroom and see me before school. Good luck and do well.